And now I just have loaded in the rock sub D object again, and this time the non-sub D version of that object. So just within Modeler, I have subdivisions turned off by using the Tab key. And now what I want to do is take a look at using this and show you how we can use it as a collision object. So first we're going to need some particles in our scene. And of course these collisions also work with hard effects and soft effects, and they do translate over to the other areas, as do the wind and gravity, because of course collision, wind, and gravity are all global. That will affect all of our different effects options and not just particles. I'm going to add in a particle emitter, and we're going to use the HV emitter and click OK. I'm going to keep with just the default group because I don't have a whole lot in the scene right now, so we don't need to worry about affecting more than one object. And I'm going to raise up this particle emitter in the scene and then change our generator size up a little bit larger, and let's go ahead and use 3 meters on all of our axes except the Y, which I'll be reducing to 0.2. And that way we have sort of a flat cube that we're going to be using, but of course it's really going to be more like a cylinder because we have the nozzle set to sphere. I'm going to set up a little bit of gravity directly within the particle, -2 on the Y, and also go to our particle and change the lifetime to 350, and then set our timeline to 350 frames. So now if we scrub through, we'll be able to see our particles falling. I'm going to move this down a little bit so it'll be able to hit our object a little bit sooner, and we won't need a longer animation time. And that's pretty much all we need to do currently for this object. So I'm going to open up the object properties with our rock sub D selected. And if you already had another object open with the object properties, you can just change that to the rock sub D. Under the Dynamics tab, we're going to add in collision, the same as we did add the emitter. Immediately it has changed the type to object. We also have object sub D and object advanced. Now with just object, we can already see the polygons and points being highlighted for our collision. And what we can do is start to scrub through our animation and see it is immediately becoming a collision object. And just by scrubbing through, we can see the overall effects and how it is bouncing, because currently our mode is set to bounce, and our bounce bind power has been increased to 200%, because the default for objects is 200%, although the default for just a standard collision is 100. So if I set this down to the standard default of just a regular collision object at 100, we're going to see the particles stick a little bit more to our surface, and that overall effect. I'm going to increase our bounce bind power to 200, back to the object default. And now if you notice, I have a lot of non-planar polygons that are showing up within our scene. And we can see the different areas where they are disappearing because they are non-planar. But that does not seem to affect our collision at all. And our particles are still not going through our object. So it's very nice that we don't have to worry about non-planars affecting this collision, and we don't have to worry about those gaps that we see as a display error affecting the calculation of our collision. And now we can also use all of the modes that are available with any collision whatsoever. So whether we're using an object or not, we can still use all of the different modes, whether we want these to just stick to our object, or we want them to be erased once they hit our object. And that also gives us a lot more variation for creating the kind of effects we were using before, where we were customizing the emitter end by using basically a child emitter to our main emitter, to have those generate once those first particles end. So what we can actually do is use Modeler to create objects with more variation, to really customize exactly where those particles are going to end. And that's one really cool way we could use this as a collision. We also have the event mode, which we still have not covered, and we'll come back to that. We can scatter our objects and our particles, so they'll scatter throughout, and we can see the effects of that below as it travels through the collision. And then, of course, the attract mode. And of course, with the attract, we'd want to use a smaller bind power. And actually, I'll go ahead and increase that to 100, and we can calculate. And that does not seem to be working correctly at the moment. Change that value down to 0% and recalculate just to see what will happen. And it's still going to flow entirely through our object. So whether or not the attract mode is going to be the best, you really have to play around with that and see, because it may not be an option that's available at the moment, or is just not working at the moment. Increase that up to 500%, and that could just be a restriction that we have with objects. Of course, with the attract mode, that really wouldn't matter too much as far as the object type. So if we change that to sphere and hit calculate, now we're going to notice it's still flowing through. We'll change our bind power to 100 and recalculate. And that seems to be a restriction with our object, so it's not correctly working. But that's really not that big of a deal, because we can always use other objects that are parented. So we'll go ahead and change this back to our bounce mode with 200 for our bounce bind power. Now what we can also do is go beyond the shape of our object very easily. Right now our radius level is set to 0, which is going to completely mold itself around the object shape. But if we wanted to, we could extend the collision beyond the surface and set that to 1 meter. And now we can see, even though the collision in the OpenGL isn't showing up correctly, our particles are now colliding with this object 1 meter around the actual surface. So we can adjust this radius and level around our object. We change this to 0.5, so now 500 millimeters from our object it will start to collide. Change that down to 0, and then we'll be able to have the exact surface. We could also go into a negative amount. We'll do negative 0.5, and that will scale down our object so that it's colliding a little bit on the inside, which you may sometimes need for certain scenes, or if you don't want it directly bouncing off the outside of the object, maybe you need it to go inside for a certain hypervoxels effect in order for it to look correct. Because of the way that hypervoxels are generated in their centers, you might need to go into the object a little. So we could even set that to a smaller amount where it's just negative 100 millimeters, and it's just slightly going into the object. And of course we can still use our probability and what the chances are of the collision object affecting our particles. If we change this down to 20%, we're going to notice that some of the particles will go through and not be affected by this object. And usually a probability amount of 100 is more than enough to guarantee the amount, and if you can see with our slider, we cannot go above 100, and if we type in a value of 200, it's basically going to be the same as if we had it set to 100, because that probability amount is pretty much fixed at an overall level of 100%, even though a lot of these other values can be a little touchy because the values can go up so high. Our bounce bind power we can bring up to a very high amount where we can see 1000%. And we notice our particles really bouncing off. Bring that down to 500. And we'll zoom out just a little. And we can see them really bouncing off the surface of our object. So that's something where we would go to much higher values, and even above the value of 1000 will actually show up. So we can see with 2000 they're really flying off. With 1000, not so much. So that is a value that we can go over. Bring that down to 200%, and we can still use the roughness, fixed power, and also friction power. Let's take a look at modifying this object. Let's go over to Modeler. We're going to turn sub D back on and switch back to layout. And now we have a subdivision surface. Now this emitter, or collision object, is still calculating for a regular object, which may be good enough to outline the overall shape of your object depending on what it is you're using as a collision and how accurate that needs to be. Because once we move to the sub D mode, it's going to use a lot more processing power in order to calculate that, because there's going to be a lot more polygons. So opening up the object properties, we can change this to object sub D, and now we can see it is reflecting our subdivisions, which will also reflect the geometry amount and how many subpatches we have. If I change our subpatch level down to 2, it will immediately reflect upon itself within our collision. So you may not even need to use the full subpatch level for your display, which will be effectively what the collision is. So you could render at that value of 3, but the display and how the calculation is for our collision we can use at a much lower amount, but still higher than it would be if we were to change this back to just object mode. And now we can see it is conforming much more, even though we don't have a ridiculous amount of polygons caused by that higher subpatch level. And once it renders, it will render the object at the higher sub D, which we can see our render amount is set to 3, but our display level and how our collision works is set to 1. And that is extremely helpful. We can also use that new group mode that's on the bottom. So if we wanted these particles to become part of a new group once they hit this object, we can easily use the change option and set a new group, and affect that with new win, just as we did before. Now the other mode that we have is Object Advanced. Now this is going to work directly with polygons and not on the subdivision surface level. And it works a little bit differently, and basically this will give you a more accurate calculation of your object. So if you're just using the standard object mode where you have a very high resolution mesh, you want extremely accurate calculations, then you can change to Object Advanced. But keep in mind that the Object Advanced mode will take a lot longer to calculate high amounts of particles, and also it will depend on the amount of polygons you have in the scene. So if we have a really high polygon amount for this collision object, depending on the power of your system, it could possibly crash it or take a very long time compared to normal to calculate that effect. So if we change our object sub D mode up a little bit higher, and now with a subpatch level of 3, go ahead and calculate this amount. It is going to reduce the speed a little bit because we have more particles, more things to calculate within the scene. Of course, there's not a lot of particles right now, so that's really not something we need to worry about too much. But depending on the complexity of your scene, you may need to adjust that. And we can see that effect showing up. We're going to go back and set that display to 1. We can see that automatically updates the way our collision object works. And let's take a look at creating a little bit of an animation with this collision object, and also increasing the birth rate of our generator. I'm going to increase our particle limit to 100,000, and also increase our birth rate to 250. And this is generating by seconds. And now we have a lot more particles in the scene, and it's still reacting very quickly. I'll increase our birth rate even higher to 350. And if we calculate this, we can take a look, and we can already see that it is calculating faster, even with the more particles that we have, because we are working with the lower subdivision amount. So definitely something to keep in mind. And for a simple object like this, it's really not going to matter too much. So now let's take our rock object, create a little bit of an animation with it. And what I want to do is move it over to the right of our scene, so on the x-axis. And we're going to scrub all the way to frame 350, and then move our object over to the side, so that it's going to be going through this flowing particles that we have. And we can see that effect. It gives a really neat look. And that's just with our standard animation of it going straight without any rotation on the rock object. And with the bounce power that we have, we can see them bouncing along the surface. And of course we can control those different amounts with all the settings we have. Let's go ahead and take a look at rotating this. We're going to go to our last frame, switch to our rotation, which we can do with Y, or using the scroll on the mouse, or also going to our Animate tab and selecting Rotate. And what I want to do is just add a bit of rotation, and we're doing this along the pitch, so it kind of tunnels around. And let's go ahead and calculate that. And we can take a look at the flow onto our object. And we can see, even with the rotation, it correctly works and looks really interesting. I'm going to increase that amount a little bit more, where we have a negative around 267 right now. I'm going to increase this to a negative 900, which is going to make it spin around a couple of times. And very quickly. It'll also throw our particles off in different variations. So I'm going to close out our panel. And now we can take a look at the animation as this rock is spinning through. And we get a really nice collision from that. And now what I want to do is create another object for collision, which is going to spray our particles around a little bit more, and we can take a look at something a little more complex of a scene and more of a usage for this. So first what I want to do is just clear our scene. We're going to switch to Modeler, create a new object, and what I want to do is just create a disk. We can pull this out, and we're going to do that on both axes. And I'm going to make this a little bit wider. I'm going to hit N on the keyboard to increase the amount of sides we have from 24 up to 48. So we'll go ahead and double that amount, just so it's a higher polygon. Hit the spacebar on the keyboard, and we're going to switch to the Polygon mode and just select our side polys. Hit B on the keyboard to bevel, and just bevel that inward a little. And that's mostly just for looks. And now we want to create another object, something to kind of fling our points around and our polygons that we're going to be creating from our emitter. So we'll go to Creative Elements, select Box, and I want to remove the segments, and these are the segments I had from creating that rock earlier. So we'll hit N on the keyboard, and we can just reset all of these segments down to 1. And I'm going to give it a little bit of depth. And now we're going to kind of tunnel out this area. So we're going to select that polygon in the front, B for bevel. And then we can right mouse click to end that bevel and start a new one. Right mouse click again to end it, and we're going to dip that in a little bit more. Right mouse click, create a new bevel, and just kind of creating an adjustment where it has a little bit of a smoother surface. Something a little more realistic to what you'd be working with if you're actually using this effect. And then I'm going to use Y on the keyboard for rotate. And I'm just going to dip this in a little. And now what I want to do is create some copies of this all the way around our object. So we can go to Multiply, and then we can select Array, and we're going to set this to radial, and we want this to be on the X, and we can increase our number. And we're going along the X-axis because that's going to act as our pole in which it will rotate itself around. And we'll do 6 of these. And click OK. And that looks pretty good. What we can do is go ahead and cut this, paste it on the next layer, and now we have a fairly interesting object that we can animate and use as a collision. And I just want to create one more object to make the scene a little more complex. And basically what I want to do is just go to Creative Elements, select Box, and we're just going to drag out this box shape. And then I am also going to add 2 segments on the X-axis. Numeric, and we can take a look and we can see there's now 3 segments on the X, and I just want to use these to modify the overall shape of this object. And actually what I'll do is go ahead and add 2 more, and you'll see why that can end up being fairly important. Go ahead and select these 2 points. We'll switch to point mode. Select these. We can hit H on the keyboard to have stretch on. Just use the stretch tool to click and drag those fairly close to each other. T to move these points together, and H again with the other sets of points. And we just want to stretch these into each other. T to move that off to the side. And we're just going to kind of create a little slide here. So we want to select these 2 inner points now. T on the keyboard. And we're going to move that down, which is going to create a nice little divot and dip into that box that we have. And I'm going to use rotation just within the object itself and set the scene up mainly within Modeler, and that way we're not really going to have to make any adjustments to the movement within layout. I'm going to hit F2 on the keyboard to center this, and then we can constrain this and pull it upward. And then I'll want to move that to the side. And our first object, we're going to do the same thing. You could just kind of move that to the center. You could hit F2 to make sure that is centered perfectly. And then we can take a look at with these 2 objects together. I'm going to go ahead and move that slide over a little bit more. And that should be good. So I can go ahead and save this out now. And we can apply surfaces if we want to change these objects. I'm going to stick with just the defaults, because we're mainly just focusing on these particles and not so much the render. And then I'm going to go ahead and save this out, and we can load it up into layout. And now we can select Send Object to Layout once it is saved. And we can see our scene, just these couple of objects. And let's go ahead and set up our dynamics. And since we just have a cleared scene, we're going to need to add in our particle emitter. And I want to position this in our scene. We're going to have this just dropping onto our slide object. And we're going to use the global gravity option of our emitter itself and not a gravity object separately for the group. Let's go ahead and select -2 for our Y gravity. Increase our frames to 500 so we can get a nice calculation of everything. Take a look at the speed. And we also want to go to our particle and increase our lifetime to 500 frames. And that looks like it should be good for our basics on our emitter. And just that basic setup. I also want to increase, in this instance, a little more at the particle limit because we are running out. So I'll increase that to 100,000 to make sure we don't run out. And actually I will increase that gravity amount to -3, just so it moves a little bit faster. Even though -9.8 would be the realistic value, we can always increase that amount a little bit more if we need to. So let's select each one of these objects. I'm going to start out with our little slide we created. Select it, hit P for properties to open it up, and in the Dynamics tab add in collision. And we have this automatically set to object. Mode is bounce. And now we're seeing a little bit of an error. Once we start to scrub through, if I hit calculate, we're noticing that some of our particles are being generated on the sides. So in this case, what I want to do is select our emitter and actually decrease the generator size 2.5 or 500 millimeters. And we're still kind of seeing that overall effect. And it could be caused by a couple of different things. So mainly what I want to do to try to correct that is to go into Modeler, select our second object, and what I'm going to do is move the rotation so it's basically back to its original state. Hit F2, we can save this, go back into layout, and now we're going to modify the position within layout and hopefully correct that problem. So now we'll just move this into position, switch to rotate. We just want to rotate this down towards our object. I'll move that back a little bit, and we can move it down. And now we still have that collision added. And we can take a look, and we're definitely noticing that it looks much better. So that can play a small role in the errors that we were having. We're going to open up the object properties and just calculate, and now we're seeing that same sort of an effect. So what I want to do is go to our collision and change this to Object Advanced. And now we can see that it's corrected the problem, because it's going to calculate more correctly to our specific object. And Object Advanced will also take into account objects that have these sorts of divots, and an object that really is more advanced, something that's more complex than the typical object that's used. So we can see this bouncing and falling into the lower part of our scene. And now what I want to do is select our other object and our wheel that we sort of created. We're going to add in collision for that as well. Change that to Object Advanced. Our mode is still set to bounce. And we can take a look at that. And what I want to do is add some rotation to that object. We're going to go all the way to our last frame, frame 500. Switch to our rotation. And I just want to increase our pitch on a negative amount. Let's go ahead and just set that to negative 360, which is going to give us one complete turn. We're going to zoom in a bit, and now we can calculate this effect. You can see those particles coming down, and then once they hit the next object, it's really going to slow down our calculation. And we can really see that happening, so we kind of just going to have to wait until that's done. And now we are finished calculating, so we can go ahead and take a look at our current scene. You can see those particles coming down, and then start to go into our other object, and they're going to get scooped up and then thrown forward. And we end up with a really neat looking effect. And we can also see that each of these areas is going to start to spit out our particles once they fill up. And what we may want to do is increase this effect a little bit quicker so we can move along through the animation a little bit further. And we can really follow those particles more and see what's happening in a longer animation. So let's go ahead to our last frame, and I'm going to take our pitch and decrease this from 360 to negative 600. Actually an increase, but since we're going negative, technically a decrease. And then I want to select our emitter object, and under the gravity, change that to negative 5. And I'm going to recalculate this now, and then we can take a look at something a little bit quicker, and that will follow along in the animation a little bit further. So we have finished calculating, and now we can take a look at our animation, something a little bit quicker. And now because we are moving faster and our gravity is more powerful, our bounce and bind power may need to be increased, or actually decreased, for the wheel object, because once we are hitting it, we are seeing some extreme areas where the objects are really bouncing out very far. But overall, we can take a look and see how each of the little scoops are starting to spit out the objects once it moves around. We get a really neat looking and complex animation. So we could add hypervoxels to this and set it up for water if we wanted to have an effect like that. Or maybe we could use a molten metal. Just a lot we can do to automate the process and set up some really neat looking collisions with these objects.